Greetings everybody. Let's take a look at this video. We'll talk about the quadratic formula. So what the quadratic formula is used for is really for solving any equation that happens to look like ax squared plus bx plus c is equal to 0. Now the first part that kind of goes into the quadratic formula that we've already discussed in a previous video is the discriminant. And the discriminant, capital D, is equal to b squared minus 4ac. Now what the discriminant tells you is actually the number of x-intercepts that quadratic is going to have. The roots of the quadratic formula, so the actual solutions, are given by two separate equations. One equation is going to be x is equal to negative b plus the square root of d over 2a. The other equation is going to be x is equal to negative b minus the square root of d over 2a. Now to see how this actually works, let's do it by looking at an example. So let's suppose that we're asked to solve 2x squared minus 11x plus 12 is equal to 0. Well, the very first thing that we're going to do is actually to identify what a, b, and c are. So in this case, a is going to be 2, b is going to be negative 11, and c is going to be 12. We then compute the discriminant, b squared minus 4ac, which is going to give us negative 11 squared minus 4 times 2 times 12. Well, negative 11 squared gives us 121. 4 times 2 is 8. 8 times 12 gives us 96. So our discriminant is going to be 121 minus 96, or 25. Our next step is to compute the square root of the discriminant. So the square root of d is equal to the square root of 25, which is just 5. Now in computing that, if for some reason the discriminants are pretty big, we might not be able to compute those by hand, we might not know them exactly, well, that's where a calculator can come in handy to help us out. Now that we have the square root of the discriminant, we're going to actually compute the roots. So computing the first one, we've got x is equal to negative b plus the square root of d over 2a. So that means since b is negative 11, we actually have negative of negative 11 plus 5 over 2 times 2. Well, negative of negative 11 gives us 11 plus 5 over 4. 11 plus 5 is 16 over 4, which gives us 4. For the second root, we have negative b minus the square root of d over 2a. So again, we have negative of negative 11 minus 5 all over 2 times 2. Well, negative of negative 11 is 11 minus 5 over 4. 11 minus 5 gives us 6. 6 over 4 simplifies to 3/2. Now to actually confirm that those roots sure enough really are roots and sure enough solutions to the equation, we can actually take these things and plug it in to our original equation. So if we wanted to check 2x squared minus 11x plus 12 is equal to 0, we just replace x with 4. So on one side we'd have 2 times 4 squared minus 11 times 4 plus 12. Well, 4 squared gives us 16. 11 times 4 is 44. 2 times 16 gives us 32. So we have 32 minus 44 plus 12. 32 minus 44 is negative 12. Negative 12 plus 12 gives us 0. And sure enough, we have 0 is equal to 0, a true statement, and we have a solution. For the other root, we plug in 3/2 for x. So we have 2 times 3/2 squared minus 11 times 3/2 plus 12. Well, 3/2 squared gives us 9/4 times 2 is going to give us 18/4. Then 11 times 3/2 gives us 33/2, and then plus our 12. Well, 18/4 simplifies to 9/2, so now we've got 9/2 minus 33/2 plus, if we convert the 12 to 24 over 2, Then we've got 9 minus 33, which gives us negative 24 over 2 plus a negative plus 24 over 2 gives us 0. And sure enough, we have 0 is equal to 0, and we have a true statement. So we found our two separate solutions to this particular equation. Let's try another example. So suppose this time that we're asked to solve x squared plus 6x minus 16 is equal to 0. Again, we kind of go back to our default form, ax squared plus bx plus c is equal to 0, and we identify a, b, and c. Well, a is going to be the number that's multiplying x squared. Since it doesn't look like we have one in this case, we really have a is going to be 1. B is going to be the number that's multiplying x, so b is 6. And c is the number on the end that doesn't have an x on it, and so that's negative 16. Computing the discriminant, we've got b squared minus 4ac, which gives us 6 squared minus 4 times 1 times negative 16. 6 squared gives us 36. 4 times 1 is 4 times negative 16 gives us positive 64. So we've got 36 plus 64, which is 100 for our discriminant. Taking the square root of the discriminant, we have the square root of 100, which is just 10. And from there, we're able to compute the roots of our quadratic. So we've got x is equal to negative b plus the square root of d all over 2a. So that's going to give us a negative 6 plus 10 over 2 times 1. Well, negative 6 plus 10 is 4. 4 divided by 2 is 2. For our other root, we've got negative b minus the square root of d over 2a. So that gives us negative 6 minus 10 over 2. Well, negative 6 minus 10 gives us negative 16 divided by 2 is negative 8. So once again, we can take those two values, 2 and negative 8, plug them in, and let's make sure that we do have solutions. So if we want to check into our x squared plus 6x minus 16 is equal to 0, we substitute in 2, so that's going to give us 2 squared plus 6 times 2 minus 16, so that's 4 plus 12 minus 16, 4 and 12 is 16, 16 minus 16 is 0. Sure enough, a true statement. If we substitute in negative 8, well, we've got negative 8 squared plus 6 times negative 8 minus 16. Well, negative 8 squared is 64. 6 times negative 8 is negative 48. So we've got 64 minus 48 minus 16. 64 minus 48 is 16. 16 minus 16 gives us 0. And again, we have a solution to our quadratic. So now let's take a look at one more example. So suppose we're asked to solve 18x squared minus 39x plus 11 is equal to 0. Same format as the two previous problems. We identify what a, b, and c are. So a is going to be 18, b is going to be negative 39, and c is going to be 11. Computing our discriminant, our b squared minus 4ac, we've got negative 39 squared minus 4 times 18 times 11. Well, now the numbers are slightly bigger, so it is pretty good to hand it over to a calculator. So 39 squared gives us 1521. If we do 4 times 18 times 11 is 792. 1521 minus 792 gives us 729. Computing the square root of the discriminant, square root of d is the square root of 729, which is 27. Again, for larger square roots, it's not a bad thing to have a calculator handy to help you compute it. So our roots, they're going to be negative b plus the square root of d over 2a. So we've got negative of negative 39 plus 27 over 2 times 18. Well, that gives us 39 plus 27 over 36. Which gives us 66 over 36, which simplifies to 11 over 6. For our other root, we've got a negative b minus the square root of d over 2a. So we've got negative of negative 11 minus 21 over 2 times 18. So that gives us 39 minus 27 over 36, but 39 minus 27 is 12 over 36, which is just 1/3. Now, just as before, we can go through and check both of these to make sure that they do give us true answers. So if we wanted to check 18x squared minus 39x plus 11, well, if x is going to be 11 over 6, that's going to give us 18 times 11 over 6 quantity squared minus 39 times 11 over 6 plus 11. Well, 11 over 6 squared is going to be 121 over 36, and 39 times 11 is going to give us 429 over 6. Well, 18 times 121 gives us 2,178 over 36 minus 429 over 6 plus 11. We're able to simplify the 2178 over 36 to 363 over 6. So now getting a common denominator of 6 for each one, we have 363 minus 429 plus 66 all over 6. Well, 363 minus 429 is negative 66, plus 66 over 6 gives us a negative 11 plus 11, and we get a 0. So sure enough, 11 over 6 is a solution. If we wanted to check our 1/3, well, now we're plugging in 18 times 1/3 squared minus 39 times 1/3 plus 11. Well, 1/3 squared is going to be 1/9. 18 times 1/9 minus 39 times 1/3 is going to give us 39 over 3 plus 11. Well, 18 over 9 is going to simplify to 2. 39 over 3 simplifies to 13. So we've got 2 minus 13 plus 11. 2 minus 13 is negative 11 plus 11. Sure enough, gives us 0, and we found our other solution to our quadratic. So what we can see from these three examples, the technique for actually computing with the quadratic, computing the roots with the quadratic formula, very straightforward. First of all, we find out what a, b, and c are. Then we compute the discriminant, b squared minus 4ac. We simplify that square root, so the square root of the discriminant, and then our two roots are given by negative b plus the square root of d over 2a and negative b minus the square root of d all over 2a. So I hope this has been pretty informative. I hope you've worked through these examples along with me on your own, and I will see you all next time.